Hey y'all, this is Ishnai Laboratories and welcome to my stream. We're about to do the check this out stream podcast. That I've decided to start calling it a podcast because I guess it fits. Um, but yeah, this is always done the first of every month on the first Thursday, and we're ready to start. Last month we also did something about Jupiter, but this time it's actually about the red spot itself rather than something flying by the red spot. Um, anyways, James Webb Space Telescope spies strange shapes above Jupiter's red great spot. Astronomers have previously unseen structures and activity and have found previously unseen structures and activity in Jupiter's atmosphere above the Great Red Spot. These odd features seem to be caused by powerful atmospheric gravity waves. The Great Red Spot is the largest storm in the solar system, twice as big as the Earth, and is believed to have been raging for at least 300 years, according to NASA. The winds of the Great Red Spot range at around 270 to 425 miles per hour, which is safe. 430, not 420, damn, to 680 kilometers per hour, and up to 3.5 times as fast as a tornado here on Earth. Yet, despite the storm's age, size, and power, scientists have actually suspected that the atmosphere of Jupiter above the Great Red Spot wasn't all that interesting. Why, though? Why? I think it'd be interesting. However, new observations delivered by the JWST Near Infrared Spectrograph instrument, which observed the massive scarlet storm in July 2022, shows that this assumption couldn't have been more wrong. We thought that this region, perhaps naively, yes, would be really boring, team leader Henrik Millen of the University of Leicester said in a statement. It is, in fact, just as interesting as the Northern Lights, if not more so. Jupiter never ceases to surprise. I mean, come on. What secrets has the Great Red Spot been hiding? Jupiter's upper atmosphere is the point at which the planet's lower atmosphere meets its magnetic field. This leads to bright northern and southern lights, powered by bombardment by charged particles from the sun, fueled by sprays of volcanic material erupting from the Jovian moon Io, the most active volcanic body in the solar system. Jupiter may be one of the brightest objects in the night sky over Earth, easily seen in clear skies. Yet apart from its northern and southern lights, the atmosphere of the solar system's largest planet only glows weakly, making it difficult for ground-based telescopes to see in detail through the Earth's atmosphere. From the JWST's position a million miles away from Earth, our planet's atmosphere is no hindrance to this $10 billion space telescope. In addition to this, the sensitivity in the infrared spectrum allows it to see the gas giant's atmosphere in intricate detail, including the region over the Great Red Spot. Aiming to discover if this region was a bit dull, Millen and his colleagues targeted. By the way, I'm sorry for slaughtering any names in this. With the the main instrument of JWST. This led to the discovery of a variety of intricate structures among the field of view, including dark arcs and bright spots. Though sunlight is responsible for the majority of the light seen from Jupiter's atmosphere, the team thinks there must be another that gives rise to the changes in the shape and structure of the upper Jovian atmosphere. One way in which you can change the structure is by gravity waves, similar to waves crashing on the beach, creating ripples in the sand. These waves are generated deep in the turbulent lower atmosphere all around the Great Red Spot, and they travel up in altitude, changing the structure and emissions of the upper atmosphere. These gravity waves are very different from gravitational waves, the latter of which are tiny ripples in space and time, predicted by Albert Einstein in his 1915 theory of general relativity. Gravity waves propagate through an atmosphere as opposed to the fabric of space-time as gravitational waves do. The atmospheric gravity waves are seen on Earth occasionally, but these Earth-bound waves are much less intense and powerful than the same phenomenon occurring over Jupiter. Well, since Jupiter is kind of bigger and also having that storm, kind of understandable. The team now hopes to follow up on the detection of these newly found great red spots features and intricate wave patterns underlying them. This future investigation could reveal how the waves flow through the gas giant's upper atmosphere, and how this causes observed structures to move. The findings are expected to help understand the distribution of energy across Jupiter and could help support the European Space Agency's mission, Jupiter Icy Moons Explorer. JUICE. I repeat, some of the names they have for these things. Oh my god. JUICE launched April 14th in 2023 and will reach Jupiter and its moon in 2031 when it... makes detailed observations of Jupiter and its 3 largest ocean moons, Ganymede, Callisto, and Europa. Team's results were published in the Journal of Nature Astronomy, and this was by Robert Lay. Alright, on to one of the title things on here. Venus is leaking carbon and oxygen, and we don't know why, by Michelle Starr. Planetary atmospheres are typically leaky things. Think about it. With no impenetrable barrier to hold it back against the void, some of it's bound to seep away and dissipate into the very tenuous medium in between the parts of space. Remember last week when we talked about that fluffy planet and how much is being lost, and it's very quickly happening? Anyways, back to this. Earth loses about 90 tons of atmospheric material a day. That's not enough to make a dent, but it does give us a few clues about why some of the other planets are the way they are. Venus, for example, is thought to have once been a temperate world like Earth, with liquid water on its surface. Now it's a scorching hell planet, choked on clouds of carbon dioxide that rain sulfuric acid. Now the spacecraft whipping past Earth's evil twin. Why is it just a different twin? It's not evil. It's just different. In a discovery that would, when combined with previous findings in the loss of hydrogen, could yield clues to a planet's startling transformation. Characterization. What am I saying? Characterizing the loss of heavy ions and understanding the escape mechanisms at Venus is crucial to understand how the planet's atmosphere was evolved and how it lost all its water. Astrophysicist Dominique Delcourt of the National Center for Scientific Research in France. In spite of being our nearest orbital neighbor and the most planet similar to the Earth in the solar system, there's not much information about Venus. There's one dedicated mission studying Venus up close at the moment, the Akatsuki orbiter, which has been studying Venus's atmosphere since 2010. Goodness! That's kind of interesting. We have more people paying attention to Jupiter. I mean... Okay. Anyways. But spacecraft on other missions are getting glimpses of Venus as they go about their other business. I repeat, names of things. Made by Colombo is a joint mission between the Japanese Aerospace Agency and the European Space Agency to study Mercury. The course of its missions include 2 close flybys of Venus, one in 2020 and the other in 2021. Yeah, goodness, they definitely haven't been talking about it. The second of which taking the probe into a part of Venus's magnetic environment that hasn't been explored before. It's kind of an interesting magnetosheath, induced magnetosphere, ions. Now, Venus doesn't have a magnetic field that's generated inside the planet like the Earth does. Rather, its magnetic field is the result of a series of interactions between charged particles in the Venus's upper atmosphere and magnetic fields and moving ions in the solar. I didn't realize that. It's kind of interesting. The result of this is a weak sphere of magnetism that forms a sort of teardrop shape. Yeah, you can kind of see it there. Could the fact that it doesn't have... Well, I mean, it... Say, one of the problems with Mars is the fact that it, its core has stopped moving. The result is a weak sphere of magnetism that forms a sort of teardrop shape, with its tail streaming away with the solar winds. Draped around the magnetosphere is the magnetosheath between the outer boundary of the magnetosphere and the compressed material called a bow shock. Why is it called that though? Imagine an item moving at supersonic speed. This object, as it moves through a medium, causes the material in the medium to pile up, compress, and heat up. The result is a shockwave known as a bioshock. A bioshock wave gets
cosmic bow shocks.
Oh, that's a bit loud. That's a bit loud. Bow? It's not bow, it's bow? Okay!
Presented by Science at NASA. Imagine an object moving at supersonic
so that's the,
This object, as it moves
narration,
causes the material in the medium to pile up, compress, and heat up.
I mean, we have shock waves there.
A type of shock wave,
yeah,
known as a bow shock. A bow shock gets its name from bow waves.
I noticed the ship.
In front of a fast-moving boat created by the force of the bow pushing forward through the water. Bow waves and bow shocks can look similar. However, bow waves only occur on the surface.
Yeah, I was about to say, it's kind of hard to do that with a...
There are bow shocks everywhere, even in space, and these cosmic bow shocks can tell scientists cosmic secrets. Even the emptiest regions of space contain protons, electrons, atoms, molecules, and
dark matter. No.
Planets, stars, and the plasma clouds ejected from supernova fly at a high speed through the surrounding medium. Cosmic bow shocks are generated in that medium.
I think there's a thing that looks like vampire teeth that might...
The fast-moving plasma of the solar wind blows past Earth, but it cannot penetrate our magnetosphere, explains Maxim Markovich of NASA's Goddard Space Flight Center.
We had last time about talking about they found some new interesting things about...
The magnetosphere is almost like a solid body for that wind, so the solar wind forms a bow shock in front of the outer edge of the magnetosphere.
They found some interesting things about the magnetosphere.
Can unlock the secrets of the solar wind, allowing us to better understand its...
That kind of makes it look like a spider, and I don't like that. I mean, I don't mind spiders.
Stars with the interstellar medium create impressive bow shock. Hot supergiant star Kappa Cassiopeia creates a shock that can be seen...
Try and say that fast. Cassiopeia.
Telescope. In this bit of image, the pileup of heated material around Kappa Cassiopeia is indicated in red. Studying stellar bow shocks can reveal the secret motions of the underlying stars, telling us how fast they're moving, which way, and what they're moving through. An example of a bow shock on an even grander scale is seen in this cluster of galaxies located in the Carina constellation, called 1E 0657558. This X-ray image from the Chandra Observatory captures the moment of a gigantic collision of two smaller clusters, the two white regions in the image. Markovich says the clusters are filled with hot plasma, and one of them, the cluster on the right, is smaller and denser. As it flies through the less dense cloud of plasma that is the bigger cluster, it forms a bow shock. Scientists study such cluster shocks to deduce their velocity in the plane of the sky. The fine structure of the shocks reveals a lot about the interesting, complicated physical processes in the plasmas present in clusters, as well as many other astrophysical
Probably should have opened that
across
better.
the universe.
I'm awake. I'm awake.
For more on shocking phenomena found beyond our solar system, stay tuned to science.nasa.gov.
Alright, back to the article. This is why Colombo, try to say that name, flew through, between Venus and the Sun, almost skimming the planet. Shoots the sneasel away. Yep. How you doing, MMO? I have some interesting anthropology articles towards the end, by the way. If I'm remembering what anthropology means, yes. I mean, it is technically science. It's all the way back here, though. Because I have it sorted by science, and technology. I'm gonna move that one a bit over here more towards. And then DNA stuff, and then, yeah. So, I have a good, you know, range. Venus is almost skimming the planet and its instruments detected oxygen and carbon, somehow accelerated sufficiently to escape Venus's gravity. This is the first time that positively charged carbon ions have been observed from escaping from Venus's atmosphere, says astrophysicist Lena Hinded of CERN's. These heavy ions that are usually slow-moving, so we are still trying to understand the mechanisms that are at play. It may be an electrostatic wind is lifting them away from the planet, or they could be accelerated through centrifugal processes. At least 3 missions are in the works to study Venus in the near future, which will hopefully shed light on the many remaining questions. This includes the escape mechanism for carbon, whether the planet is still volcanically active, and the burning question about whether life could be lurking among its clouds. And of course, how it evolved from a world that may have once been similar to our own home planet. Recent results suggest that the atmospheric escape from Venus cannot fully explain the loss of its historical water content, says astrophysicist Mona Persson of the Swedish Institute of Space Physics. This study is an important step to uncover the truth about historical evolution of the Venusian atmosphere, and upcoming missions will help fill in the gaps. What's kind of interesting is the fact that there's only been one real mission dedicated to studying Venus recently, and that was just dedicated to Venus, and that was in 2010. Think about that. And the one that we just mentioned now was planning to study Mercury, but did 2 flybys of Venus in 2020 and 2021, so it's nice that there's like 3 more missions going on that one. Alright. This is, by the way, the other one was, I think, earlier, and this one's, I think, later. And this is, this is still theory, though, mind you. This is how Venus lost its oceans. Jamie Carter. Venus is I think we've covered this. At least. So why does the desert-like hellscape... Why do they call it a hellscape? It's its own scape! Stop comparing it to anything. It's just its unique scape. Venus now has 100,000 times less water than Earth. In a new paper published today in Nature, planetary scientists argue that the water escaping from Venus twice as fast as previously thought. Escaping into space. In the study, computer simulations suggest that hydrogen atoms, specifically a molecule called HCO+, I am no whatchamacallit. I absolutely made sure to not do yep, planet C. Hydrocarbonate ion. It's a bio-including. By the way, I couldn't, when the few times in regular science when they tried to have us balance formulas, I didn't get it. It just went over my head, and I realized if chemistry was going to be a lot of that, I wasn't going to make it through. High in the planet's atmosphere, escaping into space. What water has existed in its atmosphere? It's enough to have a global ocean of about 1.2 inches, or 3 centimeters deep. The Earth's waters would create 1.9 miles, or 3 kilometers, deep global ocean. Venus has 100,000 times less water than the Earth, even though it's basically the same size and mass, said... Oh, there's a typo there. Michelle Coffin, co-leader of the study and research scientist at the Laboratory for Atmospheric and Space Physics at the University of Boulder, Colorado. The fates of Venus and Earth appear to have diverged about 1 billion years ago. Having previously received as much water as Earth, the carbon dioxide clouds in Venus's atmosphere initiated a potent greenhouse effect that vaporized water as temperatures at the surface rose to 900 degrees Fahrenheit, 482 degrees Celsius. However, HCO+ can explain why so dry. Whether the molecule is present at Venus is unclear. Well, why don't they just you know, the Space Telescope, doesn't that have a study thing for that? A spectro? Is it spectrometer or something? The finding comes in the wake of recent discovery of phosphine, a gas thought to be a sign of life on Venus. Given the present, true. Okay. Initially discovered, a gas thought. Excuse me. Phosphine, a gas thought to be a sign of life on Venus, initially discovered in 2020. Last year, it was confirmed that traces of it had been infrareded in the atmosphere of Venus. Okay, so they did. It comprises of hydrogen, phosphorus, and is a flammable toxic gas on Earth. I mean, yeah. Although space agencies have almost ignored it compared to Mars, it's beginning to change. 3 missions are being planned to learn more about Venus. NASA's Da Vinci, launching in 2029, will land a probe on its surface. Hope it doesn't burn up in the atmosphere. NASA's Veritas, launching in 2031, will map the planet's volcanoes from orbit. The European Space Agency Envision, launching in early 2030s, will analyze the planet's interior from orbit and monitor trace atmospheric gases. Sadly, none of these missions can confirm the presence of HCO+ in the planet's atmosphere. None will carry instruments incapable of detecting the HCO+. Researchers are hopeful for a future mission that might. There haven't been many missions to Venus, but a newly planned mission will leverage decades of collective experience and flourishing interest in Venus to explore the extremes of planetary atmospheres, evolution, and habitability. Habitability. Yeah, that's what I was thinking. I wanted to see this. I just wanted to. I saw it and was like, yes. I wonder what it was like. I mean, there's spaghettification or whatever. Spaghettification, yeah. But it's visualized to some degree, and I'm like sitting here going, dude. I don't know if there's actual speaking on this, but I'm betting it won't be that fast. Also, we won't be conscious or alive for it anyways. Event Horizon. So what is happening here? This is a simulation of a flight into the supreme massive black hole. Oh, can I slow it down so I can read this aloud? Into a super massive black hole surrounded by hot glowing disk of gas. Okay, that's a bit too slow. Okay. The thin inner circle is called the photon ring, and its image produced by light that has orbited the black hole one or more times before escaping. I know, right? This oval in the center of the camera's direction of travel shows the entire simulated sky. Okay. Okay, we'll have to slow that down for a second. Again. I'm just gonna keep it that way. For the camera, time slows compared to that of a faraway observer. Camera position to the orientation, so it's right there. Relative to where the camera is aiming at the photo ring's far side. It's now moving so fast that the simulation slows for a better view. So right here, if you can see that on the side. Event Horizon is right down there, okay. The camera's speed causes light sources directly ahead to brighten greatly. So we're like those coins in that, like, quarter thing. The camera begins its 10-minute plunge into the event horizon. Good that we have absolute... Is it 10-minute in the real... I bet it's a simulation thing. Sped up. Would it be that quickly to, you know, fall into the... The camera hits the, event horizon. Now. Okay. Light from the outside universe still shines in, but it can never leave. Doom, 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 doom. I forgot to turn off ads, by the way. Again, sorry. The camera is destroyed. Microseconds later, it reaches the singularity. Relative to the observer. Okay. A closer view shows just how layered and intricate the photon ring is. So cool. You know, there was pictures of some of the I don't remember which month it was that were really interesting that kind of looks like that. They took of some stars. No wait, it was not stars, it was black holes. Each band is a distorted image of the gas disk layered between the background sky. Successive bands are thinner, produced by photons that have taken an additional trip around the black hole before reaching the camera. This music is annoying me, actually. Due to the camera's speed, the entire sky appears to shift progressively forward, the sky shrinking before our eyes. Like a trip. Yeah, I know, right? Well, I mean, we are spaghettification or whatever. I mean, being this close, we're dead. We're just dead. It's just... no. On a typical laptop, the computing yes, I figured as much. Simulation would have taken more than a decade. Did it use a render farm? Discover the supercomputer at the Goddard Space Center has performed the feat in 5 days! Only using 0.3% of its processing power. Then why did it use up more of it? Also, fucking show-offs have a computer like that. Still, that's so cool. They did. Okay. People often ask about this, and simulating these difficult to imagine processes helps me connect the mathematics of relativity to actual consequences in the real universe, says Jeremy Snitman, an astrophysicist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, who created the visualizations. So I simulated two different scenarios. One where a camera, a stand-in for a daring astronaut, just misses the event horizon and slingshots back out, and one where it crosses the boundary, sealing its fate. The visualizations are available in multiple forms. Explainer videos act as a sightseeing guides, illuminating the bizarre effects of the Einstein's general theory of relativity. Visions rendered at a 360-degree videos let viewers look all around during the trip. We're not going to do that right now. The destination is a supermassive black hole with 4.3 million times the mass of our sun, equivalent to the monster located in... yeah, get dizzy. Located in the center of the galaxy. If you have the choice... oh, really? If you have the choice, you want to fall into a supermassive black hole, he explains. Stellar mass black holes, which contain up to 30 solar masses, possess much smaller event horizons and stronger tidal forces, which can rip apart approaching objects before they get to the horizon. I would rather be... This occurs because the gravitational pull at the end of the object near the black hole is much stronger than that on the other end. Infalling objects stretch out like noodles, a process astrophysics called spaghettification. The simulated black hole event horizon spans about 16 million miles, or 25 million kilometers, or about 17% of the distance from the Earth to the Sun. A flat swirling cloud of hot glowing gases called a accretion disk surrounds it and serves as a visual reference during the fall. So do glowing structures called photon rings, which form closer to the black hole from light that orbit it one or more times. A black backdrop of the starry sky as seen from Earth completes the scene. I think it explained it, yeah. In real time, the camera takes about 3 hours to fall into the event horizon, excluding almost 2 complete 30-minute orbits along the way. I think they sped it up a bit. At the event, but to anyone observing from afar, it would never quite get there. As space-time becomes more distorted closer to the horizon, the image of the camera would slow and then freeze just shy of it. That's why astronomers originally referred to black holes as frozen stars. At the event horizon, even space-time itself flows inward at the speed of light, the cosmic speed limit. Once inside, both the camera and space-time in which it's moving rush towards this black hole center, a one-dimensional point called a singularity, where the laws of physics as we know them cease to operate. When is the camera, oh, definitely. Once the camera crosses the horizon, its destruction by spaghettification is just 12.8 seconds away. From there, it's only 79,500 miles, or 128,000 kilometers to the singularity. The final leg of the voyage is over in a blink of an eye. In the alternative scenario, the camera orbits close to the event horizon, but never crosses over and escapes to safely. If an astronaut flew in a spacecraft in this 6-hour round trip while her colleagues on the mothership remained far from the black hole, she'd return 36 minutes younger than her colleagues. That's because time passes more slowly near a strong gravitational source, and when moving near the speed of light, this situation can be even more extreme. If the black hole were rapidly rotating, like the one shown in the 2014 movie Interstellar, she'll return many years younger than her shipmates. I have never seen that movie. Alright! Study confirms the rotation of the Earth's inner core has slowed. The inner core began to decrease its speed around 2010, moving much slower than the Earth's surface. Yeah, that's a good question. The University of Southern California scientists have proven the Earth's core is backtracking, slowing down in relation to the planet's surface, as shown in the new research published in Nature. Movement of the core has been debated by the scientific community for 2 decades, with some research indicating that the inner core rotates faster than the planet's surface. The new USC study proves unambiguous evidence that the inner core began to decrease its speed around 2010, moving much slower than the Earth's surface. When I first saw the seismographs that hinted at this change, I was stumped, said John Vidale, Dean Professor of Earth Science at the USC Dornsife College of Letters, Arts, and Science. But when we found 2 dozen more observations signaling the same pattern, the results were inescapable. The inner core slowed down for the first time in many decades. Other scientists have recently argued for similar and different models, but our latest study proves the most convincing result. The relativity of backtracking and slowing down. The inner core is considered to be reversing and backtracking relative to the planet's surface due to moving slightly slower instead of faster than the Earth's mantle for the first time in approximately 40 years. Relative to its speed in previous decades, the core is slowing down. Will it tell me how much? Eventually. The inner core is a solid iron-nickel sphere surrounded by the liquid iron-nickel outer core. Roughly the size of the moon, the inner core sits more than 3,000 miles under our feet and presents a challenge to researchers. It can't be visited or viewed. Scientists must use the seismic waves of earthquakes to create renderings of the Earth's core's movement. So they did it. This is... Did they check on the other atmosphere? I mean, the other hemisphere? Because this is just, you know, the Western Hemisphere. Oh, they also have... there we go. The Chinese academic thing. Vidal and Wei Wang of the Chinese Academy of Scientists utilized waveforms and repeating earthquakes in contrast to other research. Repeating earthquakes are seismic events that occur at the same location to produce identical seismograms. In this study, the researchers compiled and analyzed seismic data recorded around the South Sandwich Islands from I'm trying to figure out how many places did they do it exactly on the other side of the Earth too for the for 121 repeating earthquakes that occurred between 1991. Yeah, this is only giving one side of it. 121 repeating earthquakes that occurred from 1991 to 2023. They have also utilized data from the twin Soviet nuclear tests between 1971 and 1974, as well as repeated French and American nuclear tests from other studies of the inner core. Vidal said the inner core's slowing speed was caused by the churning of the liquid outer core that surrounds it, which generates the Earth's magnetic field, as well as gravitational tugs from dense regions of the overlaying rocky mantle. It will not tell me how much, apparently. Oh, wait. Here it goes. Alright. The implications of this change in the inner core's movement on the Earth's surface can only be speculated. Vidal says the backtracking of the inner core may alter the length of the day by fractions of a second. It's not telling me how much. It's very hard to notice, in order of a thousandth of a second, almost lost in the noise of the churning oceans and atmosphere. The USC's scientists' future research aspires to chart the trajectory of the inner core in greater detail to reveal exactly why it's shifting. The dance of the inner core might be more— but it's not telling me by how much! Let me actually see if I can pull up the original article. Okay. Here's the abstract. Main. Okay, here we go. Yeah, measurements matter. I guess they were just trying to create it for the layman's actual thing. The inner core has been known to change over the decades since the discovery of changing seismographs of repeating earthquakes. Oh wait, you wanted to know how many studies? Up here. 143 distinct pairs of repeating earthquakes, many within 16 multiplets, built from 121 earthquakes between 1991 to 23, at least in that location. And it says, we analyzed their inner core penetrating PKIKP waves recorded on the medium aperture arrays in the northern North America. We documented that many multiplets exhibit waveforms that change, then revert at later times to match earlier events. The matching waveforms reveal times at which the inner core reoccupies the same position, relative to the mantle, as it did at some point in the past. The pattern of matches, together with previous studies, demonstrates that the inner core gradually super-rotated from 2003 to 2008, and then from 2008 to 2023, sub-rotated 2 to 3 times more slowly back through the same path. These matches enable precise and unambiguous tracking of inner core progress and regression. The resolved different rates of forward and backward motion suggests that new models will be necessary for the dynamics between the inner core, outer core, and mantle. Okay. The inner core has been known to change over decades since the discovery of changing seismograms of the repeating earthquakes. The dominant interpretation of steady super-rotation over the decades has been derived from temporal changes up from tenths of a second in difference in arrival times between the PKIKP, which I should probably, for those who don't know what that is, bring that up. I was really into geography when I was younger. It is the ray paths for seismic waves penetrating the Earth. See. And later core phases in repeated earthquakes. The infrared rate of superrotation has settled to about 0.05 to 0.15 degrees per year, and the motion in the past decade may have slowed. Similar rates from the have been inferred from normal models. The PKIKP coda waves changes, the IC backscatter waves, and the antipodal core waveform changes. Fluctuating and much faster motion has also been suggested. Most recently, observation within a medium aperture high-frequency arrays and individual stations has suggested that the PKIKP coda waves from 1991 to 2017 changed over time primarily during the interval of 2001 to 2003, which is interpreted as because of the 0.5 degree IC rotation during that period and much less rotation at other times. Other studies suggest an oscillating motion. The distinct 6-year oscillation, SYO, and the length of a day, LOD, could be explained by the gravitational coupling of the mantle density anomalies and the core mantle boundary topography with the inner core boundary, ICB topography, although alternate explanations have been proposed. A reversal of motion inferred from scatterback seismic waves was consistent with the aptitude and phase predicted from the SYO patterns of the LOD oscillation. And it goes into more detail about it. And of course, this is the figure that they pulled from on that. Do you want me to keep reading about this? More the actual main for it? Okay. Because this is getting into a lot more detail than was placed, like, here. I know basically enough about this to read this. Like I said, I was, for the longest time, was really into geography. Not geography, I wanted to be a meteorologist and geologist, excuse me. Things came up and I stopped wanting to do it, but I'm still nerdy about it. And I'm quite sure if I continue reading this, somebody who comes in's eyes will glaze over. Alright. James Webb Telescope finds carbon at the dawn of the universe, challenging our understanding of when life could have emerged. The telescope has detected a key building block of life at the dawn of the universe, upending what we know about the first galaxies. The discovery, a cloud of carbon in a distant and compact galaxy, as it appeared just 350 million years after the Big Bang, marks the earliest detection of an element other than hydrogen in the universe. The results have been accepted for publication in the Journal of Astronomy and Astrophysicists, and reprint version can be found on RXIV. Is XIV... Are we going with Roman numerals? Because I'm not going to bother trying to figure those out. Proceeds to do so. I think that's 14. X10. Yeah, I think it's 14. Earlier research suggests that the carbons started from the form in large quantities relatively late, about 1 billion years after the Big Bang. Co-author Roberto... I'm so sorry. However much I slaughter some of these names. Maiolano, a professor of experimental astrophysicists at the Kavli Institute for Cosmology at the University of Cambridge, said in a statement. But we found that carbon formed much earlier and might be the oldest metal of all. Hydrogens have classified elements heavier than hydrogen and helium as metals. That's because, aside from hydrogen and trace amounts of lithium, these elements were forged inside the fiery furnaces of stars and distributed throughout the universe by star explosions called supernovas. This process of heavy element production and seeding was one thought to take many stars' lifetimes before the elements heavy enough to form planets were widely available. But the new discovery has challenged this preconception. We are surprised to see carbon so early in the universe, since it was thought that the earliest stars produced more oxygen than carbon. We thought that the carbon was enriched much later through entirely different processes, but the fact that it appears so early tells us that the very first stars may have operated very differently. To make the discovery, astronomers used the telescope to peer at an ancient galaxy known as GS-Z12. Using the telescope's near-infrared spectrograph, researchers broke down this early light into spectrums of color from which they could read the chemical fingerprints of early galaxy. What they found in the remote galaxy, which was 100,000 times less massive than that of the Milky Way, were trace amounts of oxygen and neon mixed with a strong signal of carbon. Exactly how carbon could have formed so early in the universe's life is unclear, though it could be due to stars collapsing with less energy than initially thought, according to the researchers. As carbon would have formed in the star's outer shells, this could have enabled it to escape and seed the early universe sooner than expected, instead of being sucked inside black holes formed from the collapsing stars. These observations tell us that carbon can be enriched quickly in the early universe. Lead author Francisco de Eugenio, an astrophysicist also at that location, not gonna slaughter it again, said in a statement, and because carbon is fundamental to life as we know it, it's not necessarily true that life must have evolved much later in the universe. Perhaps life emerged much earlier, although if there's life elsewhere in the universe, it may have evolved very differently than it did on Earth. I mean, obviously. Okay, Ben Turner was the writer of this. Okay, this is a bit late. It was June 29th, but I was saving this for, you know. A newly discovered asteroid larger than the Great Pyramid of Giza will zoom between Earth and the Moon Saturday. This was for June 29th. An asteroid okay. The asteroid is named 2024 MK, poses no risk to our planet. The thing is, the scary part is, let me read this paragraph aloud. A skyscraper-sized asteroid discovered 2 weeks ago We'll zoom between the Earth and the Moon. It took two weeks ago. I know we don't have that good of technology for that kind of stuff, but it's still kind of scary how... If it was something dangerous, how late it would take. At its closest approach, the space rock will pass within 184,000 miles, or 295,000 kilometers of our planet, about 3/4 the average distance between the Earth and the Moon. The asteroid named 2024 MK is estimated to be about 480 feet, or 146 meters across, which is greater than the height of a 40-story building or the Great Pyramid of Giza. During its approach, it'll be traveling roughly 21,000 miles per hour, or 34,000 kilometers an hour, according to NASA. Astronomers in South Africa discovered the asteroid on June 16th. Although the hefty space rock poses no threat to Earth, NASA classified it as a potentially hazardous asteroid due to its large size and precarious orbit, which occasionally crosses that of our planet. Shortly after its close approach to the Earth and the Moon this weekend, it will zoom back towards the asteroid belt between Mars and Jupiter and will not return to our neighborhood until 2037, according to NASA predictions. The space rock won't pose any threat to our planet then either. NASA monitors more than 35,000 near-Earth objects, or NEOs, which are space rocks that come within 120 million miles, or 195 million kilometers of the Sun, often crossing the Earth's orbit during their travels. Currently, there are no known asteroids that pose a threat to our planet for at least the next 100 years. Currently! Except it took 2 weeks to find this. Before it showed up. The close approach of the 2024 MK comes just days after an even larger asteroid called 2011 LU-21 blasted our planet. Measuring between 1.1 and 2.4 miles to 1.7 to 3.9 kilometers wide, the mountain-sized objects flew by at 4.1 million miles, or 6.6 million kilometers from Earth, or about 17 times the distance from the Moon. Despite this ample breathing room, 2011 UL-21 was the largest asteroid to come close to the Earth in 110 years, according to the Virtual Telescope Project. These back-to-back flybys fittingly preceded the World Asteroid Day, which celebrated on June 30th. The date is also the anniversary of the 1908 Tunguska asteroid impact, which, isn't that kind of creepy? Did they decide that on a, that's the reason why they decided on that day? Which demonstrates that demolished an estimated 80 million trees in Siberia over 830 square miles, or 2,150 square kilometers. That's kind of a grim reason to set that date. Brandon Spector. Alright, on to more technology that's kind of spacey. Kinda. Alright, NASA gives SpaceX 834 million to junk the International Space Station. Elon Musk's company was awarded the contract to safely deorbit the International Space Station within the next decade, which is smart because, the last thing, the United States did with Space Lab was we just let it drop where it dropped, and Australia was not happy about it. In fact, they sued us because of the space debris that landed on Australia. The largest of which, fragment, if you ever want to go, is at the Space and Rocket Center in Huntsville, Alabama. In orbit of the Earth since 1998, the ISS is due to come to the end of its operational life in or around 2030. Instead of leaving it to partially burn up in the Earth's atmosphere and crash unpredictably on the surface, NASA wants a safe, controlled re-entry and splashdown for the structure. Like I said. Skylab, oh goodness. Too big to burn. SpaceX will develop and deliver a spacecraft called the USD Orbit vehicle to bring the ISS back to Earth without risk to populated areas according to the contract terms. What's kind of occurred to me is the thing with the International Space Station is it was brought up in pieces anyways. Why don't they just detach it in pieces? Just thought. They might do that anyways. The 900,000 pound or 400,000 kilogram ISS is one of the many larger structures too massive to burn up during re-entry to the Earth's atmosphere. The USDV is expected to take several steps to develop and test. As it stands, NASA, Canada's CSA, Japan's JAXA, and the European Space Agency has committed to operating the ISS through 2030, while the Russians' Roscosmos will use it until at least 2028. The ISS will ultimately be guided to an area of the Pacific Ocean known as the Spacecraft Symmetry. Okay. An uninhabited area between New Zealand and South America. The ocean floor is home to over 263 spacecraft, including many capsules, cargo crafts, and rocket used to reach the ISS. I bet the fishies love that. Selecting a USD orbit vehicle for the International Space Station will help NASA and its international partners ensure a safe and responsible transition in low Earth orbit at the end of the space station operations, said Ken Bowser-Sox, Associate Administrator for the Space Operations Mission Directorate at the NASA headquarters in Washington, D.C. This decision also supports NASA's plans for future commercial destinations to allow and continue the use of space near Earth. Private space stations. The ISS costs NASA about $3.1 billion per year to run. It's hoped that the removal of the ISS from low Earth orbit will encourage the private space industry to construct orbiting space station both private and space agency astronauts can use on pay-per-visit basis. Yeah, that's not going to be more expensive or anything, because they'll be the only ones that can, you know, pay for it. Yeah. I mean, if it's the only one there, it's a monopoly to some degree. Have them pay however much. Several private space stations have been previewed in recent years, including Orbital Reef and Axiom Space Axion Station. Orbital Reef is a brainchild of Blue Origin and Sierra Space, but it has support from Boeing. Nobody wants support from Boeing. Redwire Space, Genus Engineering Solutions, and the Arizona State University. It will orbit 310 miles / 500 kilometers out and described as a mixed-use business park in space, so companies can establish their own business in orbit. Okay, when I used to work at a certain space museum that I didn't mention earlier, as a museum guide, the docents there were former NASA engineers and stuff. One of the things that they said was the reason why they hated private contractors from Boeing and Honeywell and all this other stuff is they would drag out projects so that they could earn more money. And like if there was a problem going on, they could fix it probably within half a day, while the private contractors would spend far more hours doing it. Well, people would be surprised how many satellites are up in space, and how many of those satellites itself aren't even working anymore? Like, it's a clutterfuck up there. I mean, stop. Shouldn't curse while doing this, should I? Blue Origin will build and launch the models on its now in development New Glenn rocket. Sierra Space will create modules using its Dream Chaser space plane to launch and land crew. And Boeing... Speaking of Boeing, I have a few articles for them. Yeah, radar arrays and serves... It's just amazing. Will supply its Starliner spacecraft. Speaking of... Yeah, I was about to say, yeah, say, hasn't like 2 whistleblowers died mysteriously? The first astronaut mission of Boeing's Starliner capsule has been extended again. Is this the... I don't remember. Mysteriously, yeah. Which one? I'm trying to figure out whether I have them in the right order. Yeah, it's the same thing, but it's from different things, and I want to read them just cause some of them have different information. The first astronaut mission to of the Boeing Starliner capsule has been extended again, with the spacecraft set to remain docked with the International Space Station until at least July 2nd. This marks the 3rd time the mission has been delayed, with initial return date of June 18th, pushed back to June 22nd. Did we actually make it? Now it's June 28th. Let me see. Let me see. Oh, it's still not. It's still not. Sorry. Supposed to be June 6th now. We'll get to that one. I mean, feel bad for the poor astronauts, but what the fuck were you expecting with what's been happening with Boeing? The extra time will allow Boeing and NASA to assess several issues which have arisen with the vehicle, including small helium leaks in its propulsion system and problems with its reaction control system thrusters. Despite the delays, NASA still has confidence in the star. Why though? Well, it's not like they have a choice. At all. Citing the spacecraft is performing well in orbit while docked to the space. However, repeating extensions are cause for concern, with many experts questioning Boeing's ability to manage complex space missions and ensure that the safety of the astronauts. Well, I mean, we can't trust them to things on the ground. Anyway, well, I mean, things in Earth's, you know, atmosphere. To manage complex, the issues with the Starliner are not new. With the spacecraft experiencing problems during its rendezvous and docking with the ISS, 5 of its 28 RCS thrusters malfunctioned, although 4 were eventually brought back online. Additionally, 5 small helium leaks were detected in the... by the way, this is the 4th of July if you hear fireworks. What? Sorry, I didn't read completely these articles. I just skimmed them. Additionally, 5 small helium leaks were detected in the propulsion system, with 1 spotted before launch. And the others cropping up after deployment. The fuck? Said I wouldn't curse, but... The delays have raised questions of the questions weren't raised before the launch. Boeing's readiness for complex space missions. And I mean, it's not like the whole thing... An ability to ensure astronaut safety. The company has faced numerous challenges this year, including whistleblower scandals and their subsequent Jeffrey Epstein, the aircraft safety issues, and now perilous situation with the Starliner. The project was seen as a chance for redemption, but it has failed to meet expectations. In contrast, SpaceX has consistently demonstrated its reliability, launching its Falcon 9 rocket almost every week and completing over 200 successful missions. The company's Crew Dragon spacecraft has been used for multiple crewed missions to the ISS and earned a reputation as the safest spacecraft in the world. SpaceX's reliability has made it a go-to option for companies facing significant issues, such as the Russian Soyuz spacecraft's coolant leak in December 2022. This is their... I am getting an ad. Or at least there's an ad for Boeing right here. There's an ad for Boeing right here. Boeing's mission is to protect, connect, and explore our world and beyond. Every day, or at least it's a press release statement, we dedicate to carrying out our mission safely and sustainably. Sorry. With revitalized spirit and unwavering... Yeah, spirit as in you kill people. They become spirits. Transparency in all we do. Bullshit! We are transforming into a better, stronger Boeing. Yeah. Better ways to assassinate people. Propelled by the spirit of innovations that's been our hallmark for over a century. Yeah. Boeing's reluctance to seek help from SpaceX is seen as significant humiliation. Yeah, I know. Propelled into the ground. Given the company's long history in aerospace and its established reputation, founded in 2002, SpaceX has rapidly gained traction due to its innovative approaches and successful missions. Both Boeing's Starliner and SpaceX Dragon were developed under NASA's Commercial Crew Program, with Boeing receiving a larger contract, of course, of $4.2 billion compared to SpaceX $2.6 billion. I wonder where that money went. Did it go to CEOs? Probably. Despite this, Boeing's Starliner has faced numerous delays and technical issues, while SpaceX's Dragon crew has been successfully used for multiple missions. Alright. On to here. Astronauts stranded. This is the same one for the July 24th, but it has a bit more information. Troubleshooting various faults in the space, but only 45 days of docking time available. The window of return is closing. 2 astronauts who rode to orbit in Boeing's Starliner are currently stranded in space aboard the International Space Station after engineers discovered numerous issues with the Boeing spacecraft. I mean, some of them were before it took off. Teams on the ground are now racing to assess Starliner's status. Astronauts Butch Wilmore and Suni Williams were originally scheduled to return to Earth on June 13th after a week aboard on the SS, but their stay has been extended a third time to go to ongoing issues. Well, apparently it's a third time. I mean, fourth time. After years of delays, it should have been more. The Starliner capsule successfully blasted. I don't consider it successful if there was a helium leak before takeoff. On its inaugural crew flight from Florida's Cape Canaveral Space Force Station at 10:52 a.m. on June 5th. But during the 25-hour spaceflight, engineers discovered 5 separate helium leaks in the space-class thruster system. Now, to give the engineers time to troubleshoot the faults, NASA announced it would push back the perilous return flight, extending the crew's stay on the space station to at least 3 weeks. It's longer now. We've learned that... this is a way of absolutely putting it. PR fuck. We learned that our helium system is not performing as designed. You think. Mark Nappy, Boeing's Starliner program manager, said at a news conference on June 18th. I be it manageable. How? It's still not working as we designed it, so we've got to figure it out. It was leaking before you lifted off. The return module of the Starliner spacecraft is currently docked at the ISS Harmony module as NASA and Boeing engineers assess the vital hardware issues aboard the vessel, including 5 helium leaks to the system that pressurizes the spacecraft's propulsion system and 5 thruster failures to its reaction control system. After powering the thrusters up on June 15, engineers found that most of these issues appeared to be at least partially resolved. But their exact causes remain unknown. However, Harmony module's limited fuel means the Starliner can only stay docked for 45 days. So the window for safe return flight is narrowing. The issues are the latest in a long list of setbacks and headaches for the Boeing spacecraft. The company built the Starliner capsule as part of NASA's Commercial Crew Program, a partnership between the agency and private companies to ferry astronauts to low Earth orbit following retirement of the NASA spacecraft shuttle in 2011. SpaceX's Crew Dragon also came up from this initiative and has ranked up to 12 crewed flights since it began operating in 2020. You know how old Boeing fucking is? And they were with the original team. But the Starliner's first uncrewed flight test was in 2019, was scuppered by a software fault that placed it in the wrong orbit. And the second attempt was held back by issues with the fuel valve. After a few more reviews last year, the company had to fix issues with the capsule's parachute and remove about a mile, 1.6 kilometers of tape that was found to be flammable. The current mission is Boeing's third attempt to take the crew to the ISS. The 2 previous were scrubbed by a vibrating oxygen valve. On the United Launch Alliance's Atlas V rocket, on which the Starliner was mounted and which was developed by Lockheed Martin. Apparently the Atlas V rocket worked just fine. It was the other stuff that didn't. And a computer glitch on the ground launched the sequencer, respectively. Also, July 3rd, or today, I can't believe this is a statement they made. And it's in the July 3rd, Boeing Starliner report. Starliner testing continues on space and on the ground. We really want to understand the thruster and how we use it in flight. I think this is the wrong time to be figuring that the fuck out. The teams on console in NASA's Mission Control Center in Houston and Boeing's Mission Control Center at Kennedy Space Center checked out various systems of the spacecraft with the crew, including repressurizing the propellant manifolds. They also conducted mission data loads, or MDLs, which are files for the spacecraft's computer to understand the current inertial and relative navigation states, Earth rotation, and thermal conditioning on thrusters used during the Starliner's return, and more. We're updating some products on board to support the continued dock duration throughout the month. You mean it's gonna be longer? It has 45 days of fuel. It has 45 days of fuel. through higher positive beta periods. There's lives aboard. We are approaching, says Chloe, marrying the Starline flight directors who's coordinated the power-up actions with Wilmore and Williams. The Starline is healthy, and no anomalies were written against the space. This is such a PR statement. It's not funny. How is it healthy if it can't make it back down to Earth? Additionally, additional Operation Checkout capabilities, or ICCs, that were added during Tuesday's testing included tablet and procedure updates. Camera and tablet batteries were also charged while the spacecraft was fully powered up. Canadian Space Agency astronaut Josh Kutrick, the Capcom, or capsule communicator, will fly on Starliner 1 following CFT, was also on console working with the crew. Do you feel safe? I would, like, say fuck no! Crew, updated the crew towards the end of that power-up that transferred the MDLs were successful, and all software updates were update! They're playing fast and loose. This is like Ubisoft levels of, or any computer game. Good communication, configuration. Good news, great work, copy all. Were replied over the SS space to ground loop. That work took place as teams at NASA's White Sands Test Facility in New Mexico prepared for the Starliner's Reaction Control System, or RCS, thruster testing. An acceptance test, which is the standard for all new thrusters, is a quality check to gather baseline performance. Did they not do an acceptance? Did they not do? The fuck? All new thrusters is a quality check to gather baseline performance. I mean, it's Boeing! It's Boeing! Together baseline performance data starting today, July 3rd. This thruster was planned for a future... Oh, it was planned for a future Starliner mission. Beginning next week, teams will run the thruster through similar conditions that the Starliner experienced after launch on the way to the space station. Oh, you mean... with the helium leak? Hi, Lone Wolf! We're talking about the Starliner. And how it's currently stuck on the ISS, and Boeing sucks. It's a Boeing creation. Phase of the test will include replicating the phase of the crew flight test from launching to docking. Then the test will be performed to replicate what the thrusters will experience from undocking and landing. Think about this. This is the lead Boeing engineer saying this. We really want to understand the thruster and how we use it in flight. We will learn a lot from the thruster firings that will be valuable for the remainder of the crew flight tests and future missions. You know we've been going to space for over 50 years. Yeah, pretty much. Well, I think it's 50 years. We really want to understand the thruster and how we use it in flight after the thing is up at the ISS. Wilmore and Williams have remained busy assisting the space station crew with organizing stowage on the orbiting laboratory. Earlier this week, Wilmore disassembled an empty NanoRax CubeSat deployer in the Japanese experiment module. I don't think skimped. I think they've been fully cut. He also prepped and viewed samples for the Moon Microscope, a demonstration that allows flight surgeons on Earth to diagnose illnesses that could provide diagnostic capabilities for crew on future missions to the Moon and Mars. Williams has conducted some routine orbital plumbing, then audited the U.S. storage items housed inside the Zar module. The crew flight test astronauts will provide an update on their mission and stay during a news conference at 11 a.m. Wednesday, July 10th. You know, there's only 45 days of fuel for the module that they are connected to on the ISS. Think about that for a second. Yesterday's photos were poignant when reviewing the courage necessary to endure such tension of such an incredible mission. Of course, with Boeing! The last few moments of the astronauts' nerves are beginning to show. Photos captured on Saturday, January 1st by Sat News. Oh, yeah. Speaking of, NASA confirms space debris in North Carolina was from the SpaceX Crew Dragon re-entry. Well, they made it back. It will continue to explore additional solutions as we learn from the discovered debris. NASA's confirmed that pieces of debris were found throughout the mountains of North Carolina are the remnants of SpaceX Crew Dragon hardware that re-entered the atmosphere in May 2024. The largest of the debris was found along a walking trail of a mountaintop resort in May 2022. I mean, 22nd! Is the size of a standard car hood and covered in fiber weave. Oh, good. Carbon fiber weave. At least it's not in the bottom of the ocean, you know, Titan. In the weeks following that discovery, several pieces were found in residents' yard throughout the region as well. A map posted to Twitter, I refuse to call it the other thing, by astronomer Jonathan McDowell that plotted the re-entry of SpaceX Crew 7 mission's trunk or service module suggested that this particular Crew Dragon hardware was likely responsible for the mess. However, it wasn't until June 20th, 2024 that NASA confirmed the debris indeed came from a Crew Dragon spacecraft. The SpaceX has confirmed the re-entry of the Dragon spacecraft trunk hardware to NASA following its service mission to the International Space Station. Well, I mean, one is better to be used for the other. And it's been a year since then. Think about that. And it's emailed to Western North Carolina journalist Justin Berger. The trunk, as SpaceX calls it, is an unpressurized section at the tail end of its Dragon spacecraft that has fins for aerodynamic control during the emergency aborts, and is able to carry cargo or small satellites. And it's fitted with solar panels that provide power to the spacecraft when it is in flight or docked to the International Space Station. Damn, that's so wow. Look at those pictures. NASA's statement confirming the source of the debris pointed out that the trunk's re-entry over California wasn't the only recent example of a Dragon trunk surviving its fiery return through the Earth's atmosphere. At least it survived! It survived! Which is saying something! Most recently, the trunks that supported SpaceX's 30th commercial services, resupply, and Crew 7 missions re-entered over Saudi Arabia and North Carolina, respectively. NASA's statement says the Dragon Crew trunk was particularly predicted to burn up entirely upon re-entry, but these and several other recent debris falls indicate it's clearly not the case. Well, it means that it's made well enough. Detective work, we talked about Perseverance for a while, we've talked about Perseverance off and on for a while, and the Sherlock instrument has been able to be fixed, which is awesome. After 6 months of effort, an instrument that helps Mars rover look for potential signs of ancient microbial life has come back online. The Sherlock, I repeat, I love how they go out of their way to try and make some of these acronyms work. The scanning habitable environments with Raman and luminescence for organics and chemicals instrument aboard NASA's Perseverance Mars rover has analyzed a rock target with its spectrometer and its camera for the first time since encountering an issue this past January. This instrument plays a key role in the mission's search for for signs of ancient microbial life on Mars. Engineers at NASA's Jet Propulsion Laboratory in Southern California confirmed on June 17 that the instrument succeeded in collecting data. 6 months of running diagnostics, testing, imagery, and data analysis, troubleshooting, and retesting couldn't come with a better conclusion, said Sherlock Principal Investigation Kevin Hand of JPL. Mounted over the rover's robotic arm, Sherlock uses 2 cameras and a laser spectrometer to search for organic compounds and minerals in the rocks that have been altered in watery environments and may reveal signs of past microbial life. On January 6th, a movable lens cover designed to protect the instrument's spectrometer and one of its camera from dust became frozen in a position that prevented Sherlock from collecting data. I guess this is showing. Okay. Analysts by the Sherlock team pointed to the malfunction of a small motor responsible for moving the protective lens's cover, as well as adjusting focus for the spectrometer and the autofocus context imager ACI camera. By testing potential solutions on a duplicate Sherlock instrument at JPL, the team began a long, meticulous evaluation process to see if and how the lens cover could be moved to the open position. Among other steps taken, the team tried heating the lens cover small motor, commanding the rover's robotic arm to rotate the Sherlock instrument under different orientations, with supporting the Mastcam-Z imagery, rocking the mechanism back and forth to loosen any debris, potentially jamming the lens's cover, and even engaging the rover's percussive drill to try Sorry, thinking of a drill. On March 3rd, the imagery returned from Perseverance showing that the ACI cover had opened more than 180 degrees. Yeah, add emergency fans for dust. Clearing the... what you need to do is just drill it. Clearing the imager's field of view, enabling the AC to place near its target. With the cover out of the way, a line of sight for the spectrometer and camera was established. We're halfway there, says Kyle Euchre, the Sherlock Deputy Principal Investigator at JPL. We still need a way to focus the instrument on a target. Without focus, the Sherlock images will be blurry, and the spectral signal would be weak. NASA already has a simulator. It's free. It's not amazing, and it's old. It's NASA's Exoplanet Excursions. Ooh, well, that's the... Nope, wrong one. That is a VR one. Did they take it off Steam? I mean, there's Starlight, but that's the one that's not very good. I swear, there was a... Did they take it down? They might have taken it down. Like, it's where you... It's a Mars thing. Not a Marsa. Well, I used to work at a space museum. Not to brag. I was fired. Because my autism kind of got in the way. Like any of the homologists, the team set about figuring out Sherlock's prescription. Since they couldn't adjust the focus of the instrument's optics, they relied on the rover's robotic arm to make minute adjustments in the distance between Sherlock and its target in order to get the best image resolution. No, it's just my autism pissed off people up in the, a specific person who was above me that had a lot of power. Sherlock was commanded to take pictures of its calibration target so that the team could check the effectiveness of this approach. The rover's robotic arm... Well, the thing is, I was too afraid to tell them that I had autism. Because that got me to lose jobs before. And I really, really loved the job. The rover's robotic arm is amazing. It can command in small quarter-millimeter steps to help us evaluate Sherlock's new focus position, and it can place Sherlock with high accuracy on a target. After testing first on Earth and then on Mars, we figured out the best distance for the robotic arm to place Sherlock is about 40 millimeters, or 1.58 inches. At that distance, the data we collect should be as good as ever. Cool looking. Look at it! Confirmation of the fine positioning of the ACI on a Martian rock target came down on May 20th. The verification on June 17th that the spectrometer is also functional checked the team's last box, confirming that Sherlock is operational. I can't wait to see what we get from it. Now that it's working. Mars is hard. Really! Bringing instruments back from the brink is even harder. Says Perseverance project manager Art Thompson of JPL. But the team never gave up. With Sherlock back online, we're continuing our explorations and sample collections. With a full complement of science instruments. We on one of the earlier streams, we talked about they found some really good stuff. Though one of the things with the things they want to test, they have to be able to set down at a pickup zone that is questionable right now on whether they're eventually going to or not. Because, you know, we're moving into the private company thing, and who wants to, you know, have the private company blow their thing up after how many years of work? While trying to get into the atmosphere and then back out. Perseverance is in the later stages of its fourth science campaign, looking for evidence of carbonate and olivine deposits on the margin unit, an area along the inside of Zero's crater rim. On Earth, carbonates typically form in the shallows of freshwater or alkaline lakes. It is hypothesized that this also might be the case for the margin unit, which was formed over 3 billion years ago. It's going to go over it here so we can at least hear that. A key objective of a Perseverance mission on Mars is astrobiology, including caching samples that may contain certain signs of ancient microbial life. They recently, I wonder if they're going to mention it in this. I mentioned, like I said in an article we did before about, in another stream, about them thinking that they found the most likely example of it. The rover will characterize the planet's geography and past climate and pave the way for human exploration of the Red Planet. It will be the first mission to collect and cache Martian rock and regolith. Subsequent NASA missions, in cooperation with the European Space Agency, will send the spacecraft to Mars to collect these sealed samples from the surface and return them to Earth for in-depth analysis, and, you know, not to release any kind of virus on us. Hardy har har jokes, quips. The Mars 2020 Perseverance mission was part of NASA's Moon to Mars exploration approach, which includes the Artemis missions to the Moon that will help prepare the human exploration of the Red Planet. NASA's Jet Propulsion Laboratory, which is managed for the agency by Caltech, built and manages operations for the Perseverance rover. Alright. Dyson spheres were theorized as a way to detect alien life. Scientists say they've found potential evidence. Okay, by the way, some of these are theories. And sometimes when I read stuff aloud, in other streams, may be found contradictory in this stream. I'm just saying this aloud now. Because it's theories. It's science. To sit there and say something is 100%. What would be the ultimate solution to energy problems of advanced civilization? Renowned British-American physicist Freeman Dyson theorized it would be a shell made up of mirrors or solar panels that completely surround a star, harnessing all the energy it produces. One should expect that within a few thousand years of entering the stage of industrial development, any intelligent species would be found occupying an artificial biosphere which is completely surrounds its parent star, wrote Dyson in a 1960 paper which he first explained the concept. If it sounds like science fiction, that's because it is. Dyson took the idea from Olaf Stapleton's 1937 novel, Star Maker, and he has always been open about that. The late scientist was a professor emeritus at the Institute of Advanced Study in Princeton, New Jersey. Ew, New Jersey. I'm joking. Or am I? Still, coming from a thinker who some in the scientific community might say have been worthy of a Nobel Prize early in his career, the concept took hold and hypothetical megastructures became known as Dyson spheres, even though the physicists later clarified that they would actually consist of loose collection of or swarms of objects traveling on independent orbits around the star. In his paper, Dyson also noted that Dyson spheres would give off waste heat detectable as infrared radiation, suggesting that looking for that byproduct would be a viable method for searching for extraterrestrial life. However, he added that infrared radiation by itself would not necessarily mean extraterrestrial intelligence, and that one of the strongest reasons for searching for such sources was that new types of natural astronomical objects might be discovered. Scientists at the time were largely receptive, not to the likelihood that alien civilizations would be found to exist, but that a search for waste energy would be a good place to look, said George Dyson, a technology writer and, oh goodness, an author and second of Dyson's 6 children via email. Science fiction from Footfall to Star Trek took the idea and ran with it, while social critics adopted the Dyson sphere as a vehicle for questioning the wisdom of unlimited technological growth. I mean, the elder Dyson himself argued it would be much more rewarding to search directly for intelligence, but technology is the only thing we have any chance of seeing. In 1960s, there was no way to actually search for Dyson spheres, but in more recent times, many researchers have looked for them, including those at the SETI Institute, a nonprofit organization with a mission to search for extraterrestrial intelligence, and the Fermi National Accelerator Laboratory, known as Fermilab. Now, a new study that looked at 5 million stars in the Milky Way galaxy suggests that 7 candidates can potentially be hosting Dyson sphere, a finding that's attracting scrutiny and alternative theories. Like I said, it's a theory, not a game theory. Joke, quips. Let me pull this up. So that we have the abstracts of it. I don't know if they go into it with the CNN, but usually they don't go into the detail, and we pull up the abstracts a lot of the time. The search for extraterrestrial intelligence is currently being pursued using multiple techniques and different wavelength bands. Dyson spheres, megastructures that could be constructed by advanced civilizations to harness radiation of their host stars, represent a potential signal that in principle may be hiding in public data already collected as a large part of astronomical surveys. In this study, we present a comprehensive search for partial Dyson spheres by analyzing optical and infrared observations from Gaia, 2MASS, and WISE. We develop a pipeline that employs multiple filters to identify potential candidates and reject interlopers in a sample of 5 million objects, which incorporates a convolutional neural network to help identify confusion in the WISE data. Finally, the pipeline identifies 7 candidates deserving of further analysis. All these objects are M dwarves, for which astrophysical phenomena, I love saying that way, sorry, cannot easily account for the observed infrared excess emission. Okay, this is okay, apparently there's updated with 2 people. Okay, we already have this hypocat harvest. Okay, we got that part up here before. Harvesting starlight harvesting could, in principle, result in different observational signals that may be detected using existing telescopes. These signatures include optical dimming of the host star due to direct obscuration. That's how we do mostly find stars nowadays, because the wobble of the star and being obscured when a planet goes by. I mean, when we find not stars but planets. And waste heat emission from absorbing structure. Consequently, searching for anomalous infrared beacons in the sky has become an alternative to traditional communication-based searches for technologically advanced civilizations. One of the advantages of searching based on Dysonian signatures is that it does not rely on the willingness of other civilizations to contact us. I mean, that's a way of putting it. Several observational projects have previously been conducted to detect individual DS. Slius 1985, Junku and Nishimura 1991, Tomofiv Karashev Promoskov, I'm sorry if I slaughter, 2000, Juku and Nishimura. The only reason why I know how to say Nishimura correctly is because of Dead Space. 2004, Cardigan, 2000. Did they take the Nishimura name from that guy? I am suddenly curious. Carrigan, 2009, Zachariason, 2018, and for the large-scale use of similar technology at extragalactic distances, Ennis, 1999, Wright, 2014, Garrett, 2015, Griffith, 2015, Zarakasun, 2015, Lackey, 2016, Olson, 2017, Shin Garrison, 2021. So the reason why I'm reading those aloud is to show that there are multiple studies on this and different perspectives to some degree. However, none of these searches have revealed any strong candidates for the Dysonian technology. Most search efforts have been aimed at individual complete diases, or employing far infrared for photometry, which is the SLES, the Jujuku, Nishimura, and the Tomofev and Kerrigan from the Infrared Astronomical Satellite RSAS. I'm sorry if I slaughter this name. Barler et al. 1984. While few considered partial DSs, which is the Junuku Nishimura in 2004, RSA scanned the skies for the fur, providing data of estimated 2.5x by 10 to the 5th power point sources. However, nowadays we rely on photometric surveys covering optical, near-infrared, and mid-infrared mirror wavelengths to reach objects counted up to estimated 10th to the 9th power targets and allow for larger search programs. But yeah. Let's see if we can... selling the method. The pipeline for identifying DS candidates involves several stages. We'll briefly describe each step. I think this is what we should... data collection. Duh. What is that? Okay, I might have to... oh, it's not even letting me... whatever that bandwidth. Something ban. It's not even letting me grab that letter. Select from Gaia to Mass and All Wise for sources within the 300 CP and detection in the 12 and 22 bands. W3. Let me see if I can grab. Okay. Response for, it should be... We're in the quantum realms at this point! Oh, wow. Figured the wise response per program. It should be quantum efficiency is... times the transmission of objects, beam splits, and okay, this is... Data files contain the wavelength in microns, the response, and the uncertainty. Does the U stand for uncertainty? The relative spectral response curves were constructed from measurements of the whole system. Ladder 2. Will it let me copy what that U looks like so I can... specifically what that U is. Oh, the... Nope, 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 I am confused. Micrometer? Micrometer. Micrometer. Fuck. Comment okay, the micrometer is a common unit of measurement for waves of the infrared radiation as well as sizes of biological cells and bacteria, and for grading wool by diameter. Okay, I understand that better. Cool. I was completely off before, but I mean, at least I understand now. No, wrong thing. Grid search. A grid search method is employed to determine each star's best fitting DS model, utilizing the combined Gaia, 2-mass, and all-wise photometry image classification to differentiate potential candidates located in nebular regions and convolutional neural networks. Based algorithm is applied to WISE images to determine if our sources exhibit features associated with nebular regions. Sometimes I end up having to search up more things than I think. Okay, just for people. I had the thing of, it kind of occurred to me whether people know what a nebula is. Since we do I do say that word a lot, is a distinct luminous part of an interstellar medium, which consists of ionized, neutral or molecular hydrogen, and also cosmic dust. Nebulae are often star-forming regions, such as the Pillars of Creation in the Eagle Nebula. These regions, formation of gas, dust, and other materials, clump together to form denser regions. Originally, the term nebula was used to describe any diffuse astronomical object, including galaxies beyond the Milky Way. The Andromeda Galaxy, for instance, was what's referred to as the Andromeda Nebula, and spiral galaxies were generated as spiral nebula. Before the true nature of galaxies was confirmed in the early 20th century by Vesper Spiloffer, Edwin Hubble, woo, and others. Edwin Hubble discovered that most nebulae are associated with stars and illuminated by starlight. He also helped categorize nebula based on the type of light spectra they produced. Okay. But yeah. Let's see. Planetary nebulae. I'm guessing we're going with, yeah. Wrong thing. Hey, cat. No, nope, no, cat. I love you. No, cat. No, cat. Not right now. Young dust-obscured stars, or stars otherwise associated with dusty nebulae, appear as common false positives in our search. Therefore, only images lacking nebular features proceed to the next step. Additional analysis. This step involves utilizing several Gaia-wise flags to assess whether the stars might exhibit an infrared excess of natural origin. Signal-to-noise ratio. Cat, what? Cat, I love you, but no, not right now. Not right now. I love you. We'll get pets after the stream. As he proceeds to prevent me from seeing the Twitch stream. Yeah. This step involves utilizing several Gaia-wise flags to assess whether the stars might exhibit an infrared excess of natural origin. Signal-to-noise ratio. Many sources with low signal-to-noise ratio, and R in W3 and W4, slip through all the previous steps. Therefore, we manually included this step, where all sources with S and R lower than 3.5 in the W3 and W4 bands are rejected. Visual inspection. We visualized inspected optical IR, NRI, and MIR images of all sorts in order to reject problematic sources of MIR radiation. Blends are most typical confounder at this step. Okay. Now we're going into the technical, but at least we have that baseline. Authors of the study published May 6th in the Journal of Weekly Monthly Notices of the Royal Astronomical Society specifically set out to search for Dyson spheres in the form of infrared heat near stars that couldn't be explained in any other way. Using historical data from telescopes that pick up infrared signatures, the research team looked at the stars located within less than 1,000 light years from Earth. We started with a sample of 5 million stars, and we applied filters to get rid of as much data contamination as possible. Lead study author Mandis Surzo, doctoral student in the Department of Physics and Astronomy in, I'm sorry, I have slaughtered your name, Uppsala University in Sweden. So far, we have 7 sources are known to be glowing in infrared, but we don't know why, so they stand out. There's no conclusive evidence that the 7 stars have Dyson spheres around them, he cautioned. It's difficult for us to find an explanation for these sources because we don't have enough data to prove what's the real cause of the infrared glow. They could be Dyson spheres because they behave like our models predicted, but they could be something else as well. Among the natural causes that could explain the infrared glow are an unlucky alignment in observation, with a galaxy in the background overlapping with the star, planetary collisions creating debris, or the fact that the stars may be young and therefore surrounded by disks of hot debris, which former planets will later form. Come on. The data used in the researchers comes from 2 active telescopes, the Wide Field Infrared Survey Explorer, or WISE, from NASA, and Gaia from the European Space Agency, as well as astronomical surveys of the sky in infrared light called the 2-micron All-Skies Survey, also known as 2MASS. I repeat! Collaboration between the University of Massachusetts and the Space Agency Jet Propulsion Laboratory took place in 1997 and 2001. The candidate stars are all red dwarfs, the most common type of star in our galaxy. They are also dimmer and smaller than our sun, which makes follow-up observations more difficult. It is unclear at this point whether the stars have planets around them, as they haven't been observed yet by any telescope that could potentially spot orbiting planets. However, many of the of the 1,000 exoplanets scientists have identified so far orbit red dwarfs, making their presence likely. Planets orbiting red dwarfs have a higher chance of being habitable. Early study published in March and using data from the same sources as new report also found that infrared anomalies among the sample dataset of 5 million stars in our galaxy. We got a job for this Webb Space Telescope. We got 53 candidates for anomalies that cannot be well explained, but can't say all of them are Dyson Sphere candidates, because that's not what we're specifically looking for. Gabriella Contadaro, a postdoctorate research fellow at the International School for Advanced Studies in Trez, Italy, who led this study earlier, she added she plans to check the candidates against Cez's model to see how many tie into it. You need to eliminate all other hypotheses and explanations before they could be a Dyson sphere. To do so, you need to also rule out that it's not some kind of debris disk or some kind of planetary collision. It also pushes the scientists forward in other astronomy, other fields of astronomy, so it's a win-win. Both scientists agree that more research is needed on the data, and ultimately they could turn to NASA's James Space Webb Telescope for more information, as it is powerful enough to observe the candidate stars directly. However, because of the lengthy and competitive procedures that regulate the use of this telescope, securing access might take some time. If Dyson spheres really exist, what could they be used for? If you picture ourselves having as much energy as the sun provides every second, we could do unheard of things. We could do interstellar travel. Yeah, scheduling through HR, absolutely. Maybe even move an entire solar system to our preferred location if we want to. Why though? I mean, I guess to make a new habitable planet. But don't hold your breath, because the technology and raw materials required to build the hypothetical structures is far beyond human. I mean, you know, somebody's trying to create a Death Star as a joke. Like, so, I mean, they are so big that everything we have on Earth would not be enough to build them. Freeman Dyson said that we should dismantle Jupiter, the whole planet, for raw materials, but I don't think it... Maybe one of the moons? That super colossal scale probably means that Dyson sphere, if they exist at all, are very rare. The importance of this work is that it provides the first strong evidence that there is not a lot of Dyson spheres in our galaxy, contrary to the expectations of some that they might be an inevitable end of state technology, of technological species expansion out into our solar system, says study co-author. Immediate black hole! Speaking of that, I think I have one on the Collider or something similar. One of the articles. Study co-author Jason Wright, a professor of astronomy and astrophysicist at Penn State University. The candidates that have been found are important because whatever they are, and likely they're stars surrounded by material of some sort of rare event, like a planetary collision. Although they could be Dyson spheres, they're rare and interesting objects. Yeah, did I remember? I had to get the links of all of them. Waking up. Yeah. I think I forgot to grab that one. Thank you for reminding of that. Say, I usually have, I create an entire location where I have all the links, but sometimes not all the links make it, so. They are rare, interesting objects. Dyson died in 2020. Wow. That's... for any of his spheres could be found, although they're just one of a dozen ideas that bear his name. As a young scientist, Dyson showed three compelling competing quantum theories that were actually the same theory. He similarly ended the competition, says William Press, the Leslie Serginger Professor of Computer Science and Integrative Biology at the University of Texas at Austin. He was not involved in this study. Later, he applied his genius to areas of astronomy, cosmology, and extraterrestrial realm, and also the very problem of nuclear proliferation here on the planet Earth. I don't know. The Dyson could be a hit or miss, if I remember correctly. Like, one of the first, vacuums I remember us having was a Dyson, and it lasted years. But then later on when we bought a new one, it was always breaking. But then again, more recently, in the sense of the way companies work is they create inevitable breakage, so you have to buy more. What is it? There's an actual term that's escaping me right now. Yeah. So that if you keep, they don't want you to keep using it. They want you to buy the newest and latest thing. Because if you keep using the other thing, you won't be buying more stuff from them. Obsolescence. Manufactured obsolescence. Many of his ideas. George Dyson also attested to his father's fascination and comprehensive reach across disciplines, taking advantage of a short attention span and adverse to bureaucracy. He contributed to 5 fields of mathematics and 11 fields of physics, as well as to theoretical biology, engineering, operations research, literature, and public affairs. God. I mean, I cover all those things, but I wouldn't say that I could contribute to them. The approach of researchers behind the new study could offer a more fruitful path in the search for extraterrestrial intelligence, says Tomo Goto, an associate professor of, I'm sorry if I slaughtered the name, associate professor of astronomy at the National Tsinghua University in Taiwan. He was also not involved in the study. Good that we state this. However, contamination by circumstellar debris disks, which mimic Dyson sphere input signatures, remains a concern, he added in the email. Authors argue that the debris disks around dwarf stars are rare, but 7 candidate authors selected out of 5 million sources are also rare. Despite this, the 7 candidates warrant further investigation with powerful telescopes for a more definitive evaluation. And here's the point where we reach about people, because it's a theory or whatever, it's a speculation, hypothesis, all this other stuff. It's people arguing back and forth. A May 23rd paper published in response to one of to this one suggests that at least 3 of the 7 have been misidentified, as Dyson spheres could instead be hot dogs. Hot dust obscured galaxies! And the remaining 4 could probably be explained as well. Because the study touches on the fundamental question of whether humankind is alone in the universe, the search for Dyson candidates straddles different fields, including basic sciences, philosophy, and religion, and therefore increase the involvement of young scientists and the interest of the scientific world in the topic, according to Zaza Asmanoff, affiliate of SETI, and associate dean of the School of Physicists at the Free University of Tbilisi in Georgia. I think that's Georgia, the country, who is also not involved. However, he added that the radiation fingerprint of the 7 Dyson sphere candidates might be explained by natural phenomena. Sorry. The hypothesis of the artificial origin of any very interesting radiation should be the last springboard when all possible natural explanations are exhausted, Asmanoff said, and for this, future research is necessary. Planned obsolescence. That's what it's called, planned obsolescence. Sorry. Me? ADHD? No. As for Dyson himself, if he was still alive, he would also be highly skeptical that these observations represent a technological signature, his son argued. But the discovery of new non-technological astronomical phenomena is actually why he thought we should go back out and look. Alright, what Wolf brought up before. A massive black hole may be waking up in a nearby galaxy. The black hole's eating behavior shows how these colossal beasts grow. In December of 2019, the sky-scanning Zwicky Transient Facility, a telescope perched on California's Palomar Mountain, alerted astronomers to a sudden flare coming from an otherwise unremarkable galaxy some 300 million light years from Earth in the constellation Virgo. The flare's intensity dipped and peaked dramatically over 4 years, but it continues to persist even today. It's usually that's unusually long for such a flare, so long in fact that it can't be explained by any typical cosmic phenomenon. Love saying that. Sorry. I know that makes it unserious sounding, but come on. It's fun. This behavior is unprecedented, says Paula Sanchez, an astronomer at the European Southern Observatory in Germany, who led the discovery in a statement. The researchers suspect we're witnessing a giant black hole lurking in the galaxy's heart as it wakes up from a deep slumber by feasting on surrounding gas. This gaseous material reaches scorching temperatures just before it falls into the cosmic oblivion. Oh, by the way, Lone Wolf, you missed at the beginning of the stream that there was a simulation of what it would be like to fall into a black hole that we watched. Yeah, say I'm serious. I mean, I can be serious, but don't expect me to be serious for long portions of time. You could probably get an hour of seriousness out of me. Like, continuous seriousness. After that, I'm gone. I'll say, this gaseous material reaches scorching temperatures just before it falls into the cosmic abyss, creating light shows detectable by the Zwicky telescope. If that's really the case, this would be the first time we spotted a black hole switch on. Kinky. Sorry! Million times heavier than our sun, this black hole has been sleeping for at least the past 2 decades. The galaxy in which it resides is SDSS 1335 plus 0728. I'm guessing that's the longitude and latitude. Yeah, the center of the faraway is constellation. So I'm guessing that's this, and then that's that now. Has been observed by astronomers for years, but a flare like the one sparked in 2019 has never been observed before in real time. Study co-author Lorena Hernandez Garcia of the Millennium Institute of Astrophysicists in Chile said in a statement. I haven't read too far into this, but just because it's 4 years for us does not mean that it isn't longer for wherever it is there. That is more. It's quickly, but not as quickly, falling into the black hole. After analyzing a combination of archival observations gathered by multiple telescopes before and after the 2019. Yep. Then a 2019 event, the researchers found the galaxy is now radiating much more light across multiple wavelengths, including ultraviolet, optical, and infrared. It's possible that the 4-year-long flare is hinting at an ill-fated star once ventured too close to the black hole and becoming shredded. But even the slowest of black hole-induced stellar deaths lasts at most a few hundred days. Astronomers are still learning about the various speeds in which the black holes gobble nearby matter, which often defines how the black hole hosts galaxies evolve over eons. The years-long flare seen here is unlikely to be due to explosive events known as supernovas that occur when stars run out of fuel supply necessary for intrinsic nuclear fusion and die, which are known to last for days or a handful of months, leaving astronomers none the wiser about what sparked the mysterious glow. With the data we have at the moment, it's impossible to disengage which of these scenarios is real. We need to keep monitoring the source. And I'm guessing, I don't know the plan, like the schedule of the Webb telescope, but in some of the earlier streams, we had showings of the visuals of different black holes that were studied, so. And this is back to what we were talking about with the Dyson sphere.